Hello my dear student friends, welcome you all to the video lecture series of network analysis. In this video lecture, we shall be discussing about how to find out the H parameter and ABCD parameter for the circuit consisting of inductor, capacitor and resistor. Okay, so let us find out first H parameter for those kind of circuit. So we'll go for finding out the H parameter for RLC circuits. Okay, fine. Okay, so let us go for example number 1. Okay, fine. So let us take example. So let us say this is nothing but our circuit diagram. Fine. Let us say this is 1 ohm, this is 2 ohm, 2 Henry, not ohm. Okay. Let us say this is 2 ohm. Let us say this is 1 farad, 2 ohm, and 1 Henry. Let us say. Okay. Fine. So step number 1 is what? You need to replace inductor and capacitors by S values. Okay. So let us do this. Okay. So over here, as this is the inductor, you are going to write it as twice S. As this is capacitor, you are going to write it as 1 upon S. This is also inductor, so you are going to write it S. Okay, fine. So you are going to modify this circuit diagram like this. So it is going to become 1 plus 2S, isn't it? Yes. Then this one is becoming, it is twice S plus 1 divided by S, and this one is becoming 2 plus S, right? 2 plus S. So this is the modified circuit diagram to which we are going to apply certain things and we are going to find out the parameters, H parameters, right? Okay, great. Now step number 2 is what? You have to write the equations of H parameter. Okay, so step number 2, you are going to write the H parameter equations, right? Okay, so what are the H parameter equation? H parameter equations are consisting of V1 and I2 at the left hand side. Okay, H parameter multiplied with I1 and V2 are at the right hand side. Okay, so don't forget it. Okay, so to find out first two parameter, what we need to do, we need to make a short circuit at output port. Yes. Okay, so let us do this. So write down step number 3 to find H11 and H21, set V2 is equals to 0. Okay, so the modified circuit diagram will be like this. So this is nothing but your modified circuit diagram. Yes, after making short circuit at port 2. Okay, this is 2 plus S, this is nothing but twice S plus 1 divided by S. This is 1 plus 2S. Okay, fine. Now what we need to do? We need to simplify the parallel combination and the series combination. Okay, so let us do the simplification of this circuit. Okay, So now these two parallel combination of these impedances, we are going to find it out. Okay, so let us say Z equivalent is equals to twice S plus 1 divided by S into 2 plus S divided by twice S plus 1 divided by S plus 2 plus S. Is that fine? Okay, now simplify this one. Okay, so 2S plus 1 multiplied by 2 plus S, this is divided by S. Now make the denominator common. Okay, so let us do the cross multiplication. Okay, so 2S plus 1 plus S into 2 plus S, and this is divided by S, so I can cancel out SS term. Is that fine? Yes. Okay, so let us expand these brackets. Okay, so 2S, let us multiply it by 2S inside the bracket. Okay, so let us multiply by this 2S to this bracket. Okay, fine. So what is going to happen? It is 4S plus 2S into S, it is becoming twice S square. Now let us multiply by 1, so it is going to become 2 plus S as it is divided by 2S plus 1 plus, now let us multiply by S inside this bracket, so 2S plus S square. Is that fine? Okay, and finally this is nothing but 2S square, 4S plus this S, it is going to become 5S plus 2 divided by, this is S square plus 5S, yes it is, no it is 4S not 5S, so this is going to become 4S plus 1. Okay, so this is your Z equivalent, right? And then this is nothing but your new circuit diagram after modification. So it is 1 plus 2S, and this is nothing but this one. Okay, now let us apply KVL. Applying KVL to the given circuit. Therefore, V1 is equals to 1 plus 2S plus 2S square plus 5S plus 2 divided by S square plus 4S plus 1. Okay, fine. Now let us do the multiplied by I1. So let us take I1 to the left hand side and let us do the cross multiplication so that we can make the denominators common. Okay, so 1 plus 2s, that will be now multiplied with this denominator. Okay, so S square plus 4s plus 1 plus this bracket, this remaining term 2s square plus 5s plus 2 and divided by that numerator. Okay, S square plus 4s plus 1, right? Okay, now let us do simplification. After simplifying, we'll be getting Z11, sorry, H11, not Z11. Okay, so after multiplying by 1, it will be as it is. Okay, so S square plus 4s plus 1. Now let us multiply by 2s. So 2s cube plus 2s into 4s, it is 8s square plus 2s, and the remaining terms as it is 2s square plus 5s plus 2. This is divided by S square plus 4s plus 1. Is it fine? Okay, so let us simplify this. 2s cube will be the highest power, so 2s cube plus, what about s square? How many terms are there? There are 3 terms, right? Okay, so 2 plus 8 10, 10 plus 1 11 s square, and finally s 4 plus 2 6, and this is also 5, so 11s, and finally this is 1 1 plus 2 3, right? So this is 3 divided by s square plus 4s plus 1. This is our h11, right? Is it fine? So we have found out first h parameter. Then next, okay, what is h21? H21 is the ratio of I2 to the I1. Okay, so let us find it out. Now we need to find out current division, or we need to apply current division rule in order to find out minus I2. Are you getting it? Okay, so let us find out minus I2. Okay, let us find out minus I2 over here. Therefore, minus I2 is equals to I1 into, so up to this point the I1 is going to come and then it is going to get splitted. Okay, so I1 multiplied by opposite branch resistor is what? 2s plus 1 divided by s, and denominator it is having addition, 2s plus 1 divided by s plus 2 plus s, and remember that we have already calculated this one, okay, over here. Got it? Okay, so let us take this term I1 to the left hand side, so I2 by I1 is equals to minus, I have transferred this minus sign to this one, 2s plus 1 divided by s, and we have already calculated this one is nothing but coming as, okay, so this is nothing but the denominator. Are you getting it? Okay, so let me write it directly as it is. So s square plus 4s plus 1, and that is also divided with s, right? Okay, so now let us cancel out this s, right, which are there into the denominators. Okay, so finally this is nothing but my h21, that is output current to the input current. Okay, and that is nothing but coming as minus of twice s plus 1 divided by s square plus 4s plus 1. So this is our second h parameter for the given circuit. Is that fine? Okay, now next is what? You need to find out other two parameters. So let us go for the step number 4. Step number 4, to find h12 and h22, what we need to do? We need to set I1 equals to 0 by open circuiting port 11 dash. Okay, so let us check it out. Yes or no? So we need to make I1 0, isn't it? So ultimately this impedance will not be in picture. Okay, but as we made I1 current equals to 0, though the V1 is not going to become 0 because V1 will be the drop across this particular resistor because of this I2. Are you getting it? Okay, so let us go for it. So this will be simply disconnected. So circuit will have only 2 plus s and 2s plus 1 divided by s will be the components. Okay, so this is nothing but 2 plus s, am I right? And this is nothing but your, what it is? It is twice s plus 1 divided by s, right? Okay, this is the only circuit. Okay, I2, V2, and this is the drop across that particular resistor, and that is nothing but your V1. Okay, so apply KVL to this. Therefore V2 is equals to 2 plus s into, sorry, okay, let it be I2 plus 2s plus 1 divided by s into I2. So let us take I2 common and let us transfer it to the left hand side. Okay, so 2 plus s plus 2s plus 1 divided by s. So let us make a denominator same. So twice s plus s square plus twice s plus 1 divided by s, right? Okay, therefore what is this? This is going to become, sorry, this is going to become s square. 2s plus 2s is 4s plus 1 divided by s. But remember that our h22 is nothing but I2 divided by V2. So let us make a reciprocal of this, and that is nothing but my h22. So make a inverse of this. Okay, so s divided by s square plus 4s plus 1. Okay, fine, great. Finally, what is finally? Finally, what is V1? V1 is nothing but drop across this one, no? Okay, so, and V2 is nothing but what? V2 is nothing but this one. Okay, fine. So V1 is equals to twice s plus 1 divided by s into I2, and V2 is nothing but what? V2 is equals to, okay, so let me write it as directly s square plus 4s plus 1 divided by s into I2. Okay, now let us take a ratio of these two. So h12 is nothing but v1 by v2. Okay, so let me take the ratio of these two. So I2 will be getting cancelled out, right? And what is the remaining terms then? Can I cancel out this s? Yes, we can. Therefore h12 is nothing but v1 divided by v2 is equals to twice s plus 1 divided by s square plus 4s plus 1 is my final h parameter. Is that fine? Hope you understood it. Okay, so like that you can apply h parameter and you can find the different values of h parameter or equations for h parameter. Okay, let us take one more example and then we'll move to ABCD parameters. Okay, so let us go for h parameter example number 2. Okay, so let us take 1 ohm, 1 farad, 2 ohm, let us say 2 farad, let us say this is 2 ohm and 2 henries. Okay, wait a minute. Okay, what is our step number 1? Step number 1 is to replace the capacitors and inductors by S. Okay, therefore the modified circuit diagram will have, now it is S plus 1 divided by S. This will be 2 plus 2S, am I right? So 2 plus 2S. What about this one? This will have 4S plus 1 divided by 2S. Okay, so this is modified circuit diagram to which we are going to apply H parameter, and we'll find out different equations for H parameters. Okay, great. So step number 2 is what? Write the equation V1 I2 H11 I1 plus H12 V2 is equals to H21 I1 plus H22 V2, right? Okay, step 3, make a short over here, right? So we are going to make short to find H11 and H21. Okay, okay, so let us draw the circuit diagram properly. This is nothing but S plus 1 divided by S. This is 2 plus 2S. 2 plus 2S, and the parallel impedance, that is nothing but 4S plus 1 divided by twice S. Okay, great. Now let us apply. First we'll need to modify the circuit diagram. Sorry. Okay, let us modify this. Let us find out Z equivalent. Okay, so 2 plus 2S multiplied with 4S plus 1 divided by twice S, and it is 2 plus 2S plus 4S plus 1 divided by 2S. Go for the simplification. Okay, so 2 plus 2S into this bracket 4S plus 1 divided by twice S, sorry. So it is twice S divided by, now let us multiply by 2S to this so that we can make the common denominator. So 4S plus 4S square plus 4S plus 1, that will be divided by 2S, and we can cancel out this 2S with this 2S, right? Okay, now simplify it. 4 into 2 8S plus 2 plus 8S square plus 2S divided by 4S square plus 8S plus 1, and then finally this is going to become 8S square plus 10S plus 2 divided by 4S square plus 8S plus 1, right? Okay, and then that will be in series with this particular resistor, that is S plus 1 divided by S, and this is Z equivalent 1. Okay, now apply KVL and find out H11. So V1 is equals to S plus 1 divided by S plus 8S square plus 10S plus 2 divided by 4S square plus 8S plus 1 into I1. Am I right? Take this I1 to the term to the left hand side, and then it is going to become V1 by I1 is equals to. Now let us do the cross multiplication so that we can make the common denominator. Okay, so S plus 1 4S square plus 8S plus 1 plus S into 8S square plus 10S plus 2 divided by S into bracket 4S square plus 8S plus 1. Okay, so let us simplify this. Let us multiply by S inside this bracket. So 4S cube plus 8S square plus S plus, let us multiply by now 1, 4S square plus 8S plus 1 plus, now let us multiply by S inside this bracket, 8S cube plus 10S square plus 2S, and denominator divided by 4S cube plus 8S square plus 1S. Okay, now let us simplify this. Check out S cube terms. So there are two S cube terms. So 8 plus 4, it is becoming 12 S cube plus, how about S square? So 8 plus 4 is 12, 12 plus 10, 22 S square. So 22 S square plus, what about S? So 1, 1 plus 8, 9, 9 plus 2, 11. 11, yes. And what about constant? Only one term is there, that is 1. Okay, divided by this 4 S cube plus 8S square plus S. Is that fine? So this is our ZH11. Are you getting it? Great. So this is my H11. Okay, now let us find out the other parameter, that is H21. Okay, so in order to find out that, what we need to do? We need to find out current. Okay, so let us go for the current division rule. Okay, let me write it over here. Okay, minus I2 is equals to I1 into 2 plus 2s divided by, because this is the opposite branch resistor, no? Yes, so 2 plus 2s plus 4s plus 1 divided by 2s. Okay, and you already calculated this one. Is that fine? Okay, over here. Okay, so this is nothing but the term. Okay, or this one is the final term, so don't forget it. Okay, so let us take I1 term to the left hand side and let us transfer that minus sign to the left hand side. So I2 divided by I1 is the final term. Okay, 2 plus 2s divided by 4s square plus 8s plus 1 divided by twice s. This will be as it is because there is no divided by twice s. Okay, so this term will be going to the numerator. Is that fine? And this is becoming minus. Okay, because we have transferred that minus sign to the right hand side. Okay, so I2 divided by I1 is equals to minus of, now let us multiply by twice s to this bracket. Okay, so it is going to become 4s plus 4s square, right, divided by 4s square plus 8s plus 1, and this is your h12, sorry, 21. Is it fine? Great. Now let us find out other two parameters. So step number 4, to find h12 and h22, set I1 is equals to 0, right? Okay, so once we are going to set I1 is equals to 0, this resistor will not be in picture. Okay, so therefore only two resistor, two impedances were there, will be there. Okay, so these are the two resistors, this not where, this will not be there. Okay, sorry. So this is nothing but 4s plus 1 divided by twice s, and this is nothing but what is that? Okay, let me recall it. I think it is 2 plus 2s. Was it? Yes, it is 2 plus 2s. Now let us apply KVL. Okay, so V2 is equals to 2 plus 2s plus 4s plus 1 divided by twice s multiplied with I2. I think you already calculated this one. Okay, so that is nothing but, no, I don't think so. Let me check it out. So while calculating your Z equivalent, you might have calculated it. Okay, yes, it is. Yes. Okay, so this is nothing but the, yes, this one you already calculated, and that was, finally you have got it as this one, I think. And finally, yes, it is there. Okay, divided by twice s again. Okay, so 4s square plus 8s plus 1 divided by twice s. Okay, so this will be 4s square plus 4s square plus 8s plus 1 8s plus 1 divided by twice s, that is V2 divided by I2. But we need to make a inverse of this because h22 is nothing but I2 divided by V2, right? So therefore twice s divided by 4s square plus 8s plus 1. So this is my final h22. Okay, now V2 is nothing but what? This into I2, right? Okay, so from this let me write it. V2 is equals to, sorry, rare, what is happening? So V2 is equals to V2 is equals to Okay, 4s square plus 8s plus 1 divided by twice s into I2. Okay, fine. And what about V1? V1 is nothing but that drop across 2 plus 2s because of I2. So we need to take a ratio. Okay, so H12 is nothing but V1 divided by V2 is equals to 2 plus 2s into I2 divided by 4s square plus 8s plus 1, and that is also divided by 2s into I2. So I2 will be getting cancelled out. This 2s will be going into the numerator. So therefore H12 is equals to V1 by V2 is equals to, so let us multiply by 2s to that 2 plus 2s, so it is going to become 4s plus 4s square divided by the remaining term 4s square plus 8s plus 1. Got it? Okay, so this is nothing but the way you can find out H parameter for the circuit consisting of inductor, capacitors and resistor. Is that fine? Thank you. Hello my dear friends. So now let us start with the ABCD parameters. Okay, ABCD parameters for RLC type of circuit. Okay, so let us take a example. Let us say 1 ohm, 1 Henry, 1 ohm, 2 Henry, 1 ohm, 1 farad. Okay, so let us take simple example. Fine. Okay, so what we need to do, we need to replace farads by 1 of 1 s. This is twice s, sorry, 2 Henry it must be, so it must be twice s, right? Okay, so therefore 1 plus 1 by s, this is going to become s plus 1 divided by s, right? Then this is going to become 1 plus 2s, 1 plus 2s, and finally it is going to become 1 plus s, or it can be written as s plus 1, no problem. Okay, so this is our first step. Is that fine? Okay, great. So let us write now ABCD parameter equation. So remember that step number 2 is nothing but writing your equations. So V1 and I1 both input currents and voltage we have mentioned at the left hand side, and AV2 minus BI2 and CV2 minus DI2. Is that fine? Okay, so to find out first two parameter, what we need to do, we need to open circuit this port, right? So let us open it first. Okay, so step number 3, to find A and C, open port 2. Okay, so therefore I2 is going to become 0 in that case. Okay, therefore the circuit will consist of only these two impedances. Fine, so s plus 1 divided by s, and this one is nothing but what, 1 plus 2s. That's it. Though we have made I2 is equals to 0, V2 will not become 0, right? V2 is the drop across this one. Okay, 1 plus 2s. Okay, what is the A? A is nothing but the ratio of V1 to the V2, right? So remember that. So let us find out first V1 and V2. Okay, so let us apply KVL so that we can find out V1. Okay, so V1 is nothing but S plus 1 divided by S plus 1 plus 2S into I1. Okay, so therefore S plus 1. Now let us do the cross multiplication so that we can make the denominator common. So S plus twice S square, after multiplying by S, this is going to become S plus twice S square divided by S. Is that fine? I1. So twice S square plus twice S plus 1 divided by S is nothing but my V1, right? What about V2? Let us find out V2 then. V2 is nothing but drop across 1 plus 2S, right? Because of I1. Now let us take this ratio V1 to V2, and that is my A. So A is equals to V1 to the V2. Am I right? So therefore twice S square plus twice S plus 1 divided by S, this is multiplied by I1 divided by 1 plus 2S into I1. So I1 will be getting cancelled out. Therefore this S is going to come to the denominator, right? Okay, so therefore 2S square plus 2S plus 1 divided by, now S into 1 plus 2S, so therefore S plus twice S square after multiplying with this bracket by S. Okay, great. So this is nothing but our A. So A is nothing but V1 by V2 is equals to 2S square plus 2S plus 1, sorry, plus 1 divided by 2S square plus S. So this is our first parameter of ABCD. Okay, now how to find out other parameter? So this is nothing but C. C is nothing but I1 by V2. Okay, so from this, can I get it C? Yes, definitely I can get it. Okay, so therefore let us take I1 to the left hand side. So V2 divided by I1 is equals to 1 plus 2S, but my C is what? C is nothing but I1 by V2. So therefore I need to take the reciprocal of this. Okay, so let us take the reciprocal of this. Therefore taking reciprocal, I1 by V2 is equals to my C, and that is nothing but 1 divided by 1 plus 2S. So this is my second parameter. Okay, I hope you got it. Fine. Now next is what? We need to make V2 is equals to 0 by making short circuit across this point. Okay, so let us do this one. Okay, step number 4, to find what? B and D, set V2 is equals to 0. Okay, so therefore after making V2 is equals to 0, this kind of circuit will have. Okay, so let us recall the circuit parameters. Okay, so this is S plus 1, this is twice S plus 1, and this is S plus 1 divided by S. s plus 1 divided by s. This is twice s plus 1 and this is s plus 1, right? Okay, let us do the parallel combination. Let us reduce the parallel combination. Okay, now remember that what you need to remember. So b is nothing but v1 by i2, right? Okay, b is nothing but v1 by i2. So you need to arrange i1 in such a way that you must have v1 term. That will see accordingly. Okay, and then we need to go for the current division rule. Okay, so these are the two steps, right? So firstly we will simplify this network. Okay, so let us take this one. Fine, so z equivalent is nothing but twice s plus 1 into s plus 1 divided by their addition, twice s plus 1 plus s plus 1. So therefore let us simplify it. So twice s into s, twice s square, plus twice s into 1 is twice s plus s plus 1. That's it. Okay, so 3s plus 2, addition of this. Okay, so therefore 2s square plus 3s plus 1 divided by 3s plus 2. Okay, now the circuit will have this kind of connection, and that is z equivalent 1. Okay, so this is s plus 1 divided by s, right? Okay, now apply KVL. V1 is equals to s plus 1 divided by s plus twice s square plus 3s plus 1 divided by 3s plus 2 multiplied by I1. Okay, fine. So let us take V1 divided by I1 like this. Okay, and let us do the cross multiplication. Yes, so that we can make the denominators common. S plus 1 into 3s plus 2 plus s into 2s square plus 3s plus 1 divided by s into 3s plus 2. Great. So let us multiply inside this bracket. Okay, so s, let us multiply by s first. 3s square plus 2s plus 3s plus 2 after multiplying by 1. Okay, now let us multiply by s inside that bracket. So 2s cube plus 3s square plus s divided by 3s square plus 2s. Okay, so finally 2s cube first. Let us add s square terms. 3 plus 3, 6s square plus 2 plus 3, 5 and 1, 6s plus 2 divided by 3s square plus 2s. So this is V1 by I1. But what we need to find out, what is the B? B is nothing but V1 by I2. And what is D? D is nothing but I1 by I2. Okay, so first let us find out D. Okay, by simply applying current division rule. Is that fine? Okay, so over here this is the current I2, right? Up to this point I1 will come, right? Therefore we need to find out minus I2. So let us first find out minus I2. Minus I2 is equals to I1 into opposite branch resistor 2s plus 1 divided by 2s plus 1 plus S plus 1. Okay, total resistance. Take this term to the left hand side. So minus I2 divided by I1 is nothing but my D, isn't it? And minus sign is also there in that particular ratio, right? In this particular ratio, minus is also important. So no need to transfer that minus to the left hand side, okay? Or right hand side, sorry. So 2s plus 1 divided by 3s plus 2. This is our D. Got it? Okay, now, okay, so in order to find out C, you need to express I1 in such a way that it will have a V1 term. Okay, so let us rearrange this equation so that we can get I1 in such a way that, so let us first take a reciprocal of this. So 3s square plus 2s divided by 2s cube plus 6s square plus 6s plus 2. And now let us transfer this V1 to the right hand side. Therefore, I1 is equals to 3s square plus 2s divided by 2s cube plus 6s square plus 6s plus 2, right, multiplied by V1. Okay, now we are going to use this in this. Minus I2 is equals to I1 into 2s plus 1 divided by 3s plus 2. Sorry, that is nothing but what? This one. Okay, is that fine? So we have taken this one, and now we are going to put I1 in that particular equation. Are you getting it? So we are going to put it over here. Okay, so let us put I1. So what is I1? I1 is nothing but this one. Getting? Okay, so minus I2 is equals to 3s square plus twice s into V1, okay, divided by 2s cube plus 6s square plus 6s plus 2 into a remaining term, that is 2s plus 1 divided by 3s plus 2. Got it? Okay, now let us transfer. Let us find out what is B. B is nothing but V1 by I2. Okay, so let us first find out I2 by V1 and then we'll make a reciprocal of this, right? Okay, now let us transfer this V1 to the left hand side. Minus I2 divided by V1 is equals to, okay, now let us take S common from this so that I can cancel out this with this. Okay, so S is common, 3s plus 2 into 2s plus 1 divided by, sorry, 2s cube plus 6s square plus 6s plus 2 multiplied with 3s plus 2, so that I can cancel out these two. Is that fine? Okay, I2 by V1 is equals to 2s square plus s divided by 2s cube plus 6s square plus 6s plus 2. Okay, and finally we need to take reciprocal. Okay, so therefore finally minus V1 by I2 is our D, and that is coming as 2s cube plus 6s 6s square plus 6s plus 2 divided by 2s square plus s. This is my D. So likewise you can find out ABCD parameter for the circuit consisting of RL and C components. Okay, thank you.